You're lying in bed, eyes closed, mind finally slowing down. Your body feels heavy, half gone already. Then, your whole leg jerks, like you just missed a step that wasn't there. Your brain, for one split second, thought you were falling to your death. This is called a hypnic jerk, and it happens to almost everyone, often without them ever remembering it the next morning. But what your brain is actually doing in that half second says something stranger about what falling asleep really is, and it's not the peaceful shutdown you think it is. Sleep. Researchers at institutions like Stanford's Sleep Medicine Center have tracked this exact moment for decades, and the term for it is a hypnagogic jerk. Hypnagogic meaning the transition zone between waking and sleep. Somewhere between 60 and 70% of people experience them regularly, according to surveys cited by the American Academy of Sleep Medicine. That's not a rare glitch. That's most of the population, most nights twitching their way into unconsciousness. The transition itself is worth slowing down on, because it isn't a light switch. Falling asleep is a gradual handoff between two systems that don't always communicate cleanly. Your brainwaves shift from the fast, irregular pattern of waking alertness into slower theta waves. Your core body temperature drops by roughly half a degree. Your heart rate eases downward. And your muscle tone, the low-level tension that keeps your posture upright even when you're just sitting still, starts to release joint by joint, almost like a building powering down floor by floor. All of this happens over a window of several minutes, not an instant. And it's precisely in that window, when systems are only partway switched over, that the jerk tends to strike. But here's where it gets interesting. Nobody agrees on exactly why it happens. One leading theory, sometimes credited to neurologists studying the reticular activating system, is that your brain's motor control and your muscles briefly fall out of sync during the transition to sleep. Your brain lowers your heart rate, your breathing slows, your muscles begin to relax, but the signal telling your muscles, you're safe, let go, and the signal telling your brain, you're now offline, don't always arrive at the same moment. For a fraction of a second, your brain reads that muscle relaxation as something else entirely, falling. It's the same reflex that would fire if you actually lost your footing off a ledge. Your brain doesn't have a separate alarm system for falling asleep versus falling off a cliff. It just has one system for sudden loss of control, and it fires first, asks questions never. What makes this stranger is the timing mismatch itself. Muscle relaxation happens gradually and predictably. The misread doesn't. It's not that your brain is constantly on edge during sleep onset. It's that this one specific moment, when tone drops past a certain threshold, seems to cross some kind of tripwire. Below that threshold, you drift off fine. Right at it, something fires. Cross it slowly enough, on a calm enough night, and you might glide past it without a single twitch. Cross it fast, and your whole leg remembers a fall that never happened. But here's where it gets interesting. There's a second, older theory that some researchers still take seriously. It comes from evolutionary biology, and it goes back to when our ancestors slept in trees. A team referencing this idea, including sleep scientists at institutions like the University of Colorado Boulder, has pointed out that a sudden muscle relaxation jolt would have been a useful survival mechanism for a primate drifting off in a branch. If your grip loosened as you fell asleep, a jerk that yanked you back to alertness for half a second could be the difference between staying on the branch and not. Your legs today have never touched a tree branch, but the reflex, if this theory holds, is millions of years old. Older than beds, older than blankets, older than the idea of sleeping lying down at all. That's the part that never fully lands until you sit with it. The twitch isn't a malfunction. It might be a body doing exactly what it was built to do, in an environment that no longer exists. You're not glitching. You're running inherited software on hardware. It was never updated for a fall-catching reflex still on duty long after there was ever a branch to fall from. It's Worth noting, these two theories aren't actually in competition. The mismatched signal explanation describes the mechanism, what's happening in the nervous system in that instant. The evolutionary account describes the purpose, why a mechanism like that would have been worth keeping around in the first place. One explains the how, the other explains the why bother. Most researchers treat them as complementary rather than rival answers. But here's where it gets interesting. The hypnic jerk is not the same thing as the paralysis that shows up later in the night, and the difference tells you something about how deliberate sleep actually is. Once you're fully asleep and drop into REM, your body doesn't relax by accident. It gets locked down on purpose. Researchers studying REM sleep have identified a mechanism, sometimes called REM atonia, where the brainstem actively suppresses signals to your major muscles so you can't act out your dreams. It's not a loosening. It's closer to a switch being deliberately thrown. The hypnic jerk happens in the opposite kind of moment, before that switch has been thrown, while your body is still mid-transition and nothing has locked into place yet. One is your nervous system carefully, deliberately shutting a door. The other is a door swinging on its hinges for a second before it's caught. Put them side by side and the hypnic jerk starts to look less like an error and more like evidence that sleep isn't a single event at all. It's a sequence of separate systems switching off one at a time, in a particular order, and the switch is the one moment things aren't yet under full control. But here's where it gets interesting. Hypnic jerks aren't random. Researchers studying sleep onset, including teams publishing through the journal Sleep Medicine Reviews, have found they're more frequent and more intense under specific conditions: high caffeine intake, sleep deprivation, intense physical exertion earlier in the day, and, most consistently, stress and anxiety. One study tracking self-reported jerks found people under high stress reported them at nearly double the rate of people in low-stress periods. Your body doesn't fully separate unsafe from unsettled. Stress keeps a low-grade alarm running, and that alarm doesn't know the difference between a wolf outside the cave and an email you haven't answered. There's a practical thread here too. Sleep clinicians often ask patients reporting frequent, intense jerks about their caffeine timing and evening exercise, because both raise the general excitability of the nervous system right when it's trying to power down. A wired nervous system doesn't fully quiet, and the handoff into sleep gets rougher for it. The jerk, in that sense, isn't the problem. It's a symptom of a system that hasn't been given enough runway to slow down, which means the nights you're most likely to feel that jolt are exactly the nights you least expect it. Not when you're calm and ready for bed, but when you're wired, behind schedule, and forcing your body to power down faster than it wants to. But here's where it gets interesting. Most people never remember it happening. The jerk itself lasts a fraction of a second, and because it occurs right at the edge of consciousness, your brain often doesn't encode it as a memory at all. The people who do remember are usually the ones it startles fully awake, which happens in a minority of cases, but leaves a stronger impression precisely because it interrupted something. That's a strange kind of bias. The version of this experience you remember is the exception, not the rule. Most nights, your brain quietly overrides a false alarm and you never even know the vote happened. Think about what that means for how you understand your own sleep. If you've ever said you don't really twitch before bed, that's probably not true. It's more likely that you twitch like everyone else, and your brain simply never files the paperwork. The version of the night you remember in the morning is already a heavily edited one, and this is one of the first cuts made. You're not a more peaceful sleeper than anyone else. You're just a worse witness to your own descent into sleep than you think you are. It also means the people who've never noticed and the people who twitch themselves fully awake most nights aren't necessarily having different experiences. They might be having the same one, filtered through different thresholds for what counts as disruptive enough to remember. Somewhere on any given night, a partner or a pet might register the jerk you'll never know happened. An outside witness to a fall your own memory decided wasn't worth keeping. Here's the wrinkle. In rare cases, what looks like a hypnic jerk isn't one. Neurologists distinguish it from a separate condition called periodic limb movement disorder, where the jerks repeat rhythmically through the night and actually fragment sleep quality, sometimes without the person waking up enough to notice why they feel exhausted the next day. A single jerk on the way to sleep is considered entirely normal. A pattern of them, every 20 to 40 seconds, night after night, is something a sleep specialist would want to look at. So, the same reflex that's harmless in isolation can, in a different rhythm, become the reason someone can't figure out why they're tired all the time. The difference between normal and worth checking isn't the twitch itself, it's the rhythm. One jerk is your brain double-checking a threshold it crosses every night.